Hi everyone, welcome to Chem 432 lab. Today we'll be doing a Fischer esterification reaction, and specifically this is the preparation of methyl benzoate. So when you guys first get into lab, you'll be checking the equipment in your lockers. All of you will have this big gray box that should contain all the equipment you will need throughout the semester. This includes beakers, Erlenmeyer flasks, graduated cylinders, Hirsch funnels, and also vials to collect your product after you're finished with your experiment. Also, some of you will have an orange box that contains specialized equipment for workups, general techniques like reflux, and also purification procedures like simple distillation that you will be doing in this experiment. So to start off the experiment, I'm first going to put a stir bar into a 50 milliliter round bottom flask. So now we're going to go ahead and add the 5 grams of benzoic acid to our 50 milliliter round bottom flask. I'm first going to start off with folding the filter paper in half and using something to secure it onto the fume hood so it is stable while I'm pouring the benzoic acid onto it. Here is my 5 grams of benzoic acid already pre-weighed out, but for you guys it might not be. Now I'm going to start off by adding the benzoic acid part by part with the filter paper into the round bottom flask. I'm not going to pour in the 5 grams all at once because when I go to pour it into the 50 ml round bottom flask, it might spill out. So now I'm going to fold the filter paper in half a bit and concentrate the benzoic acid onto the crease of the filter paper. And now I'm going to go ahead and funnel the benzoic acid into the 50 milliliter round bottom flask. So you might notice that some of the benzoic acid is stuck on the top of the 50 milliliter round bottom flask. You can go ahead and try to use your spatula to scrape the remaining benzoic acid into the flask so it will react with the methanol and the sulfuric acid catalyst. If you don't get all of it into the round bottom, that's fine. You can always use some of your methanol when you're pouring it to try to get the benzoic acid into the flask. So now I'm going to go ahead and measure out 12.55 milliliters of methanol using this graduated cylinder. I'm also going to be using this glass funnel for more careful and controlled pouring of the methanol into the graduated cylinder, which reduces the likelihood of the methanol spilling. So here's the methanol reagent that I will be using. I'm going to go and uncap the bottle of the methanol and proceed to pour it through the glass funnel. While you're pouring the methanol, it is okay if some drops of methanol spill out, but just try not to get too much of the methanol onto the fume hood. I'm now going to go and remove the glass funnel from the graduated cylinder. So here I have my 10 milliliters of methanol, and I will proceed to pour the methanol into the 50 milliliter round bottom flask. When you're pouring, make sure to pour it carefully so you ensure all the methanol gets inside the round bottom flask. So here I've measured out the rest of the methanol that I need, which is 2.55 milliliters. I will now proceed to add the methanol into the round bottom flask. After I do this, I will have added all the methanol I need for this experiment. So before moving on to the next part of this lab, I just wanted to give you guys a safety tip about using methanol in this lab. Methanol is a highly flammable reagent and it is hard to see when it burns. So make sure you have no sources of heat on while pouring the methanol, such as a stir plate or a thermal well. And you guys won't need to use the stir plate for the purpose of heating in this lab. Also, make sure to rinse your glassware with acetone, such as the glass funnel and graduated cylinder, before pouring other reagents, such as sulfuric acid, to avoid cross-contamination. So I will now be adding the sulfuric acid catalyst to my reaction. I will again be using the glass funnel to carefully pour the acid into the graduated cylinder. You guys will be using highly concentrated sulfuric acid, so make sure you are wearing nitrile gloves when you're doing this. I will now proceed to carefully open the cap of the sulfuric acid and pour it through the glass funnel into the graduated cylinder. I will be measuring out about 1.5 milliliters of the sulfuric acid. So I will now proceed to add the 1.5 milliliters of sulfuric acid into my 50 milliliter round bottom flask. I will be combining it with the benzoic acid and methanol that I previously added. I will now gently swirl the contents of the flask together, ensuring that some mixing is happening before I start to reflux the reaction. So now we're going to start to reflux the reaction. This is what the reflux apparatus should look like in your fume hood. If you want more details about how to set it up, please look in your lab manual under General Techniques. Make sure you are plugging the thermal well directly into the power adapter and not the power outlet in the fume hood. This is so you can control the amount of heat supplied to the reaction while it is refluxing. The lower water inline is connected to the green nozzle while the upper water outline flows down to the sink. We are refluxing the reaction in order to supply it enough energy to get past the activation barrier and push the equilibrium towards the products. This also accelerates the rate of the reaction. We will now let the reaction reflux for 1 hour. 1 hour has passed and the reaction is done refluxing. After about 5 minutes, I have removed the reflux condenser from the 50 ml round bottom flask. After waiting for another 5 minutes, I am now transferring the round bottom flask to a cork ring to allow it to cool further for another 10 to 15 minutes until it is only warm to the touch before I work it up. While waiting for my reaction to cool down, I will begin to set up the equipment I will need for my workup. First, I have attached a ring clamp to the ring stand and the fume hood. Next, I have a 125 ml set funnel that I will also need for the workup. I am beginning to gently place it in the ring clamp. Please make sure the stopcock is closed before you start your workup. As a reminder, when the stopcock is horizontal, that means it is closed. You will also need 2 125 ml Erlenmeyer flasks for your workup. You will need one for your organic layer and one for your aqueous layer. I will now proceed to take one of the Erlenmeyer flasks and place it underneath the set funnel to start my workup. I have also measured 25 ml of DI water into this graduated cylinder. Before I begin to pour the DI water into the set funnel, I will once again make sure my stopcock is closed. Just as a reminder, when the stopcock is horizontal, that means it is closed. Now I will proceed to carefully pour my DI water into the set funnel. Now that the reaction is sufficiently cool, I will begin to place this glass funnel on top of the set funnel. This is to ensure that all of my reaction gets into the set funnel. Now I will begin to take my reaction, making sure the round bottom flask is sufficiently cool, and begin to carefully pour that into my set funnel. This is what my reaction mixture looks like after I have poured it into the set funnel. I have now measured out 25 ml of chloroform in this graduated cylinder and will add that to my 50 ml round bottom flask. This is to ensure that my product dissolves in the chloroform and is able to be transferred into the set funnel for extraction. I am now proceeding to take the 50 ml round bottom flask with chloroform and carefully pour that into my set funnel. I will now proceed to take the glass funnel off of the set funnel. As you can see, 2 layers have formed in my set funnel. The bottom layer will be the organic layer and the top layer will be the aqueous layer. This is because chloroform is more dense than water. I am now proceeding to place a stopper on the set funnel and carefully taking it out of the ring clamp. Next, I will proceed to shake and vent the set funnel 3 times to make sure the organic and aqueous layers are thoroughly mixed together. After I am done shaking and venting the set funnel, I will now begin to carefully place it back on the ring clamp. I will now take the stopper off of the set funnel and wait for the organic and aqueous layers to separate before I begin extracting. Now I am ready to begin the extraction. Just as a reminder, the organic layer is the bottom layer and the aqueous layer is the top layer. The organic layer contains your product, so make sure not to throw that away. Now I am beginning to extract my organic layer into the 125 ml Erlenmeyer flask. Now I am proceeding to close the stopcock and have finished draining my organic layer. Now I am proceeding to drain my aqueous layer into the other Erlenmeyer flask that I had before. As you can see, I am now proceeding to open the stopcock and drain the aqueous layer. Now I have finished draining my aqueous layer. I have 2 Erlenmeyer flasks, one with my organic layer and one with my aqueous layer. Please make sure to label your Erlenmeyer flask so you do not get the 2 layers confused. Now I am taking my organic layer in this Erlenmeyer flask and proceeding to pour it back into my set funnel. As you can see, now I have my organic layer back in my set funnel. I have also measured out 15 more mils of DI water in this graduated cylinder. I will now begin to pour the DI water into my set funnel to get rid of any aqueous impurities that may still be present in my organic layer. As you can see, I now have two layers back in my set funnel, my aqueous layer on top and organic layer on the bottom. I will now begin to place a stopper back onto my set funnel. I will also begin to carefully remove my set funnel from my ring clamp. After doing so, I will shake and vent my set funnel frequently for a total of 3 times as I did before to make sure my organic and aqueous layers are thoroughly mixed together before I begin to drain them. After finishing this, I will place my set funnel carefully back onto the ring clamp once again. I will also proceed to remove the stopper from the set funnel before I begin my next step. I will now begin to drain my organic layer into my other Erlenmeyer flask. I will now proceed to finish draining my organic layer. After draining my organic layer, I will now proceed to drain my aqueous layer into the Erlenmeyer flask that I had before. I will now begin to place my glass funnel back on top of my set funnel. After doing so, I will get my Erlenmeyer flask, which contains my organic layer, and begin to pour that back into my set funnel so I can proceed with my next step. I have now measured out 15 mils of sodium bicarbonate into this graduated cylinder. The sodium bicarbonate quenches the sulfuric acid catalyst that we use in our reaction and brings it to the aqueous layer. Now I will begin to pour the 15 mils of sodium bicarbonate into the set funnel. I'm now proceeding to put the stopper back on the set funnel. In addition to using sodium bicarbonate to quench the sulfuric acid, sodium bicarbonate is used to bring any unreacted methyl benzoate to the aqueous layer. The reaction between the unreacted methyl benzoate and the sodium bicarbonate produces CO2 gas, so please make sure you are shaking and venting the funnel carefully and frequently. I'm now placing the set funnel back onto the ring clamp and waiting for the two layers to separate. I have also found that swirling the set funnel can help remove any emulsions present and help you better extract your organic layer. I will now proceed to drain my bottom organic layer back into the Erlenmeyer flask. I will now begin to drain my aqueous layer into a separate Erlenmeyer flask. I will now test the pH of my aqueous sodium bicarbonate rinse. Using a piece of red litmus paper, I will carefully dip it into the aqueous solution. If the red litmus paper does not turn blue, that means that the solution is not basic enough, and that you should rinse your organic layer 2 to 3 more times with sodium bicarbonate. I have now measured out 15 mils of saturated sodium chloride into this graduated cylinder. The saturated sodium chloride helps get rid of any aqueous impurities that could still be present in your organic layer. I will now place a glass funnel on top of the set funnel. After doing so, I will grab my organic layer, which was back in this Erlenmeyer flask, and pour it back into the set funnel. I now have my 15 mils of saturated sodium chloride that I measured out previously. Now I will begin to pour the 15 mils of saturated sodium chloride through the glass funnel and back into my set funnel. I will now remove my glass funnel from my set funnel. After doing this, I will grab my stopper and place that on top of my set funnel as well and begin to carefully remove it from the ring clamp. After doing so, I will begin to shake and vent my set funnel frequently for a total of 3 times to make sure my organic and aqueous layers are thoroughly mixed together before proceeding with the extraction. After I've done this, I will carefully place my set funnel back onto the ring clamp and begin to remove the stopper so I can begin my extraction. As you can see, I am now opening my set funnel and beginning to drain my organic layer into this Erlenmeyer flask. I am now closing my set funnel and I have finished draining my organic layer. After doing so, I will grab my Erlenmeyer flask with my previous aqueous washes and begin to open my set funnel so I can begin draining my aqueous layer into this Erlenmeyer flask. I will now begin to add anhydrous sodium sulfate into my organic layer. The sodium sulfate helps to absorb any excess water that could still be present in your reaction. I am now getting a spatula and scooping up some of the sodium sulfate and will pour that into my Erlenmeyer flask. If you notice that the sodium sulfate particles are clumping together, that could be an indicator that water is still present in your reaction. However, if you see that the sodium sulfate particles are mainly free floating, that means that most of the water is most likely gone from your reaction. I will now begin to drain the organic layer from the sodium sulfate. I have placed a glass funnel on top of a round bottom flask. I will also fold a filter paper in half twice and place that on top of my glass funnel as well. You can also slowly decant your organic layer into the round bottom flask if you would like as well. I have now taken some of the chloroform and poured that into this beaker. After doing so, I will pour the beaker with chloroform onto the filter paper. This is to make sure that the filter paper stays in place when I go to pour my organic layer. I now have my Erlenmeyer flask that contains my organic layer and also the sodium sulfate. I will begin to swirl it gently. After doing so, I will pour the organic layer along with the sodium sulfate through the filter paper and into the round bottom flask. The filter paper catches any sodium sulfate and prevents it from going into the round bottom flask. I am waiting for my organic layer to finish draining into my round bottom flask. Once it has finished draining, I will be ready for my simple distillation procedure. The purification we will be using is called a simple distillation. A simple distillation separates compounds based off of their boiling points. The compound with the lower boiling point will elute off first, while the compound with the higher boiling point will elute off second. This is my setup for the simple distillation. More detailed instructions can be found in your lab manual as well. As you can see, a thermometer is also attached to the simple distillation apparatus. This is to measure the temperature inside of the round bottom flask so I can know when to start collecting my compound. The contents inside of my round bottom flask have now started boiling. This includes my chloroform solvent and the methyl benzoate product. Since I know that chloroform has a lower boiling point than methyl benzoate, I have placed a waste beaker to start collecting the chloroform. I can also confirm that it is chloroform coming out by looking at the temperature. Right now the temperature is 60 degrees Celsius, which is the boiling point of chloroform. Therefore, I know that my methyl benzoate product has not started coming out yet. I am now starting to collect my methyl benzoate product. I have placed a clean charred vial underneath the beaker to collect the methyl benzoate. I can confirm methyl benzoate is coming out by looking at the temperature. Right now it is 198 degrees Celsius and methyl benzoate boils at 199 degrees Celsius. Therefore, I can confirm that I'm collecting the methyl benzoate product. The methyl benzoate has now finished coming off of the simple distillation. Also, an important note, make sure you never distill to dryness. Therefore, make sure that some liquid is still left in the round bottom flask before you finish your distillation. I am now capping the vial with my methyl benzoate product. After doing so, make sure you also get an NMR and determine the percent yield of your product. I am now going to dispose of the waste that I have generated during this experiment. I am grabbing my Erlenmeyer flask with my aqueous waste along with my filter paper. I am now walking to the fume hood that contains all the waste for this experiment. This includes the organic waste, aqueous waste, and also the solid waste. This is the jar for the aqueous waste in this experiment. Notice that it has labels of the different substances that it will contain. I am now proceeding to open the cap and will pour the aqueous waste in this Erlenmeyer flask into the aqueous waste container. I will now dispose of the chloroform that I collected during the simple distillation. This will go in the organic waste jar. As you can see, it is labeled with chloroform and methanol. Therefore, these substances should go in the organic waste and not the aqueous waste. I will now proceed to open the cap and pour the chloroform into the organic waste container. I will now dispose of the solid waste in this experiment. The solid waste goes into a separate container. This includes the sodium sulfate that I generated during my workup. I will now pour this into the solid waste container. I will now dispose of the filter paper in this experiment. This also goes into the solid waste as well. I will now open the lid of the solid waste container and proceed to place the filter paper into the solid waste. Thank you guys so much for listening, and please feel free to email us if you have any questions.